Okay, follow along with your scratch paper for the Math on the Spot video.
Something fishy is up. But that actually reminds me of a fun riddle which will allow us to write some inequalities about sea otters. Let's check it out for ourselves and see if we can get out of this jam. So here's a chart, and what I want us to do is to use this chart to write two inequalities that represent some kind of generalizations about the number of sea otter pups per raft. So you see here are the different raft numbers, and these are the number of sea otter pups that are actually on each of the rafts. So let's see if we can actually write some inequalities, in fact two inequalities that capture some information about them. Well, first of all, I need to actually decide on an unknown, and let's let that be n. So let's let n represent the number of pups. So the number of sea otter pups per raft. So that's what n is going to represent. So for raft 1, n would be the number 7. For raft 2, n would be the number 10 because there are 10 pups on raft 2, and so n would equal 10. Okay, well, so what kind of inequality might we consider? Well, why don't we take a look at the least number of pups anywhere. So I'm going to keep track of the smallest number we see. So 7, that's small. 10 is bigger, 15 is greater, 23 is greater, 6. Ooh, 6 is even smaller than 7, so that's the new lowest. 16, 20, and 6, so that ties. So in fact, we see that the fewest number or the least number of pups is 6. So we could actually write an inequality using that fact. We could say that the number of pups that appears on these rafts is greater than or equal to 6, because 6 is the least number. And so I could write that as n is greater than or equal to 6. So there's our first inequality that we created using the table. So that's kind of fun. Now, can we create another one? Well, one thing is we can consider the opposite. We can see the greatest number that we see. So what's the greatest number? So I'm going to look for the biggest number. So 7's the biggest right now. Oh, 10's even bigger, so 10's bigger. 15's even bigger, so 15 is the new champion. 23, that's huge. 6 is small. 16 is smaller than 23. 20 is still smaller than 23, and 6. So that's the largest right there. That's the greatest, which means that the number of pups will always be less than or equal to that number. And so I could write that down and say that n is less than or equal to 23, because 23 is the greatest number that we'd see there, and all other such n will be either that level or smaller, that number or smaller. So there's another inequality. So look, that's exactly what we were challenged to do, to see if we could find two inequalities that would generalize information about the pups on this table, and we actually did that. Isn't that great? You know, the great thing about thinking about mathematics is that it allows us to see new insights. Now we're seeing that we could even create these kind of extensions or generalizations of equalities, these inequalities, to actually represent all sorts of things. It's really, really exciting. And I had a huge time, and I know you did too. In fact, I could even say that I had a whale of a time. Have fun thinking about math, and we'll see you soon.
Thanks for watching, and I'll see you on the next one.